Guys doing today? Awesome. I'm doing well myself, so little tired, little ill, little amazing. Well, as long as amazing's mixed into the equation, that's all that matters. All right, so I told you today was going to be kind of a shortened class. I think there were two examples we didn't get through from 8.01, and the rest of the time is going to be yours for working. If you want to stay in here, you're more than welcome to, but you don't need to. So I foresee it kind of being a shortened class for sure here. Before I jump into the two equations that we just had left here in this lesson, were there any questions regarding 8.01 so far? And that's fine. I mean, you have a few days to get that done. There were a few errors. I should talk about the Unit 7 test. There were a few errors with the Unit 7 test. I think I found them all and have corrected them. If something still looks a little weird as you're working through corrections, obviously send me an email and let me know. An ellipse is similar to a circle. But it's not the exact same thing. So a circle will have a radius that never changes. So you're going to have the same distance all around from the center, but with an ellipse, you won't. There will be kind of a major axis and a minor axis to your ellipse. So we will explore that more in detail and in depth when we get to that lesson, and I think it might actually be the next one, 8.02. But it is coming up, so we will explore those ellipses and circles more in one of these upcoming lessons. But they technically are not the same thing, but they have very similar formulas. So there's only slight differences between the two formulas. Yes, you can make corrections on your Unit 7 test. Yep. And some of you may have actually seen your scores change just a little bit since I first graded it because of an error that popped up. I think it was question 4, right, Tommy? It was question 4 that had the error with it. Yeah. So I had to go back and readjust a few things with that one. So that should be all taken care of now. Okay, good. Any other questions, like regarding the test or anything at all? Or anything about our conic section so far? Okay, then where we had left off was technically right here. We only have two examples left to look at with our parabolas. And again, you're going to notice that I have that formula screen, or whatever you want to call it, up there for us to constantly be looking back at so we can pull the correct formulas for our problem here. All right, this one says to find an equation in standard form for the parabola that satisfies the given conditions. So they give us the focus and the directrix. The first thing I want us to identify is which formula we need to be looking at. Should we be looking at column 1 or column 2? It is going to be the first. If we take a look at the directrix, I think is the major one that's going to give it away. Notice that's y equals. So when I look at that directrix row, I want the one that has the y equals. And sometimes our eyes play tricks on us with how things line up. So if you saw that x equals and y equals down here, that might have thrown you for a loop and made you choose that column 2. But it is going to be our column 1 for once. Yes. A lot of our examples were in that column 2 in Tuesday's class, so it's nice to be working over here. Another thing that we can take a look at, well, I don't even know if that focus would necessarily identify quite which column to use, but the directrix really does. All right, so now that we have that directrix, let's figure out what H, K, and P are going to be. I think the easiest thing to look at is the focus and the directrix for that K plus P and K minus P portion. So if I set this up, K plus P in my focus will equal 5, right? Because that's the Y value of the point in the focus. The directrix is K minus P. Ooh, that K got a little bit large there. And we know that the directrix equals -5. So what can I do here to identify my K and P values? I would just set them, make the 5 negative and set them equal to each other. You could do that. I would probably use elimination like Isaias had mentioned, but you could do that. If you want to multiply everything through equation 1 by a -1, that is definitely an option that you could do. I'm just going to use Isaias's method there because the p's are already opposite signs and they're the same value in front, the same coefficient. So I'm going to add these two together. When I add them together, I get 2k equals 0. Therefore, what is my value of k? 0. So if k is 0, what is p? Yep, p is going to be 5. And we can also pull what h is as well. If we take a look at that focus, what is the value for h? Yeah, so we actually notice the vertex is going to be at 0, 0. We do have everything we need, though, to write our equation because we have k, p, and h. So looking at the standard equation, we're going to do x minus h, which was 0, equals 4 times p, which we said was 5, times y minus k, which was 0. If I go ahead and simplify this, I'll get just an x squared equals 20 times y. All right, not too bad. Any questions with that at all? All right, just one more left to look at here. It says find the equation in standard form for the parabola that satisfies the given conditions again. This time they're telling us the vertex is at 2, -1. It opens upward and it has a focal width of 16. So which column should we be looking at for writing our equation? 1 or 2? So Rebecca says the first column again. Anybody agree or think we need to use column 2? Isaias is going to agree. What made you guys say column 1? You are correct. It is column 1. The opening upwards. Yep. So opening upwards tells us that we have to use this column 1 information. All right, so knowing that, what is the value for h and what is our value for k? Because again, we're trying to write an equation here, so we'll need h, k, and p. H is 2 and k is -1, and that comes from the vertex. Good, because our vertex is always labeled h comma k. So the last thing we need is the value for p, and we're going to use our focal width for that. If the focal width is 4p, yep, we're going to set that equal to 16 and work backwards to solve. Isaias gets 4. Could it be -4? Yes, it could be -4. Let me take a look. It could possibly be a -4. However, I'm trying to see if that would make, if P was negative, I think that might make it open downward versus upward. So that opening upward, I think, is also going to be our indication that P should be positive versus the negative aspect of it. If it were opening downward, I do believe that P would be the -4 value. Okay. So that's a good point to kind of look out for because you have that absolute value sign around your 4P. So we are going to use +4 there so that it's opening upward. And we can graph these in just a moment here and see if that's going to be the case. Let's get our equations though to actually graph. So we're going to do x minus h squared equals 4 times 4 times y minus k. Y would be, or k is a -1, so minus a -1 turns into a plus there. So I'm just going to multiply that 4 times 4 together to get this equation. All right, we could technically try to graph it in our graphing calculator, but GeoGebra is going to be the easiest to do because we don't have to isolate the y values in order to graph in GeoGebra. So let's open GeoGebra real quick and let's just compare two equations. Let's compare the one we boxed up and let's compare if it would have been a -4. So that would be a -16 out front. Let's just verify that that +4 is going to open upward and the -4 would open downward. Okay, so let me application share. I'm sure you guys are probably working on this as well. If I move my screen over here, can you guys still see it or not? Okay, I didn't think so. I don't know why it's not liking moving it to my second monitor. I'm going to move it back. This may not be picked up on the recording, so we'll see. All right, so the first one here is the top one. Notice how it's bolded. It is an exact reflection, right? This is the one with our +16. So when we let P equal a +4, we got it opening upwards. And then notice when P was that negative, it was in fact opening downwards. So that opening up versus opening down does play a role in what our value for P will be. So that was a really good point to take a look at there that Tommy made us examine a little bit closer. Any questions with the graphs here and the equations that we ended up with for them? Okay. All right. That was the last example that we really had to look for these parabola conic sections. Were there any major questions with these parabolas that we looked at, not only here today, but also in Tuesday's class? All right, that's all I got for you then. So, like I said, I figured this would be kind of a shortened class. I will let you guys go so you can work on that 8.01 lesson. If you run into any questions with it, obviously let me know, send me an email, sign up for office hours. I think you guys are going to be just fine on it though. as you move forward here. If you want to stick around, you are more than welcome to hang out and work. Otherwise, you don't need to. You are free to leave. All right, have a great weekend, you guys. Next week, we'll be taking a look at lessons 8.02 and 8.03, I believe. All right, have a great weekend. Bye.
Recording stopped.